So here are some example log sheets from quite a busy voyage, just enough time to write down whatever the ship's display had on offer in terms of latitude, longitude. So in this case it's giving me degrees and then decimalised minutes. So there's all those examples. Different ships use different formats, and somehow you need to unify all of the different formats of data from different instruments and different times. So we'll take this example as a working point, and then just to see what else we've got. So when we read out the full ship track, so every 10 seconds or more, we suddenly get decimal degrees, and that's much more useful. And then when you've got data given to you by other scientists, by your colleagues, it's polite, really, and useful if everybody uses the same thing. So in this case, the degrees, latitude and longitude have already been decimalised. Our task is to convert degrees and decimalised minutes into decimalised degrees. So to start, let's just remind ourselves that 1 degree is 60 minutes by convention, and if we divide both sides by 60 here, we find our conversion factor to go from minutes to degrees. So 1 minute is equal to 1/60th of a degree. So that's how we go from minutes to decimal degrees. The example that we chose was 60 degrees and then 0.115 minutes. So let's convert these minutes into degrees, and then we can add the two together to get our decimal degrees. So 0.115 minutes is equal to 0.115 divided by 60 degrees. So this sum up here is equal to 60 degrees plus these degrees here, 0.115 divided by 60 degrees. For the answer is going to be 0.115 divided by 60 to go from decimal minutes to degrees, and then add 60 degrees here. 60 degrees south was an unfortunate location to check for this, never mind. So our total answer is 60.00191666, etc. degrees. So that's our conversion for the latitude. And the next question that we really need to check is how many of these points here are meaningful. And to do this, I'm just going to quickly flip back to our original value. So this value of decimal minutes, if we convert the minutes back into seconds, at least we can see what precision the seconds were measured in, or what precision the seconds were written down in. So 0.115 minutes is how many seconds? So we know that 1 minute is 60 seconds. And to go from minutes into seconds, then we simply multiply by 60. So we've got 0.115 times 60 seconds, which is 0.115 times 60, 6.9. So in this case, the seconds were reported to one decimal figure, one decimal place. And if we could try assuming if our error, or our precision, is plus or minus 0.1 seconds, well, what's that in degrees, so that we can apply it to the other number that we had. So we're going to go back the other way again. So 0.1 seconds is 0.1 divided by 60 to go to minutes, and divide by 60 to go to degrees. So we have 0.1 divided by 60 times 60, which is 360. So it's 0.00027, and I'm going to round that last 7 up to an 8 degrees. So let's just shuffle this back and compare. So at the very least, the fourth decimal place is significant. The fifth and the sixth decimal places might be of interest. So we've got 1, 2, 3, 4. The 9 we definitely want to keep. Possibly the 1 and the 6, maybe rounded, we want to keep. And that gives us a good agreement between the precision with which the seconds were recorded and the decimal value that we're reporting here. To go further, you can either refer to the GPS positional accuracy that may be recorded in the NMEA code. It may be reported by the ship's summary system, so when you ask for a record of all of the positions, sometimes the accuracy will be recorded. And some ships have 2 or 3 different GPS systems, so you can get a really firm handle on what the actual error of the measurement was just by comparing the 3 systems and looking for the difference in the locations. If we put this into Excel, we probably want to have some columns of latitude and longitude data. So I'm going to call that degrees north, minutes north, seconds north, and I have a column for the result, decimal degrees north. Okay, so probably you're familiar with how we write down the sum for Excel. So instead of writing actually the values themselves, we use the columns and the rows to refer to them. So our original sum, which was 60 plus 0 plus 6.9 over 60 times 1 over 60 now looks like this. A2 is our sulfur degrees plus B2 plus C2 over 60 all times 1 over 60. So that's probably pretty straightforward as a sum, and the important thing is that we're starting to use references or variables instead of the actual numbers themselves. 2 plus C2 over 60 divided by 60. Okay. The other thing is that in Excel, if we want to repeat this for many measurements, we simply copy down the formula box and it fills in automatically, but we still have to take in some manual activity here, so we have to type some stuff in. So we can abstract this one level further by saying instead of having a cell number, A1, A2, A3, we can just write this as, say, X degrees plus Y minutes plus Z seconds. And that's the literal equivalency for going from something like Excel into something like Matlab. And in the next session, we'll start the first Matlab program.